This is project 15 of Hacking with Swift. It's another technique project, and this time it's a really important one. We're talking core animation. This is a fundamental technique in iOS used in many places that sadly so many folks just don't think is important. They think animation can be just disabled, get on with it, get to the functionality. But the truth is, making things move, scale, and so on is not just about making things pretty, although that's certainly a large part. Its main purpose is to give users a sense of scale of what's changing and why, to help them sense a state change in your application and follow how to get back and forward within it. It's very powerful for that, and core animation is astonishingly good. It's really such a wonderful Apple framework to use. So we'll be making a little sandbox in this project so we can play around safely and see how it works. For more information, see the website hackingwithswift.com. You can buy this tutorial and all the tutorials as ebooks for just $3 per book. It's amazingly priced, and your support does help me make more videos. You can also buy these videos in high resolution, so everything looks fantastic. You really enjoy all the game projects. It looks glorious. Alternatively, find me on Twitter. You can follow me there. I am at 2straws. If you have questions, feedback, comments, news, suggestions, I don't know what, get in touch with me and I'll do my best to help you out. Okay, don't just take my word for it. Let's see how awesome core animation is. Of course, at the same time, because I love squeezing learning is, you are going to learn all about other stuff too, not least switch case, a fantastic bit of syntax in Swift. Anyway, go to Xcode and press Create New Project. Then from the list, please choose Single View Application from iOS Application. I'll name mine Project 15. For device, I'm going to choose iPad. I suggest you do the same, so there's lots of space on the screen so we can see what we're doing. Then press Next and save it to your desktop. Now please download the files for this project. I have mine already. What it contains actually is not a great deal. There's a content folder which contains a penguin. It's a slightly bigger one than we had in the last game, but it's still a penguin. You can either drag that whole folder in or just the two files, whatever makes you happy. Just drop it into your project. Make sure copy items if needed is chosen, create groups, and press finish. Boom. We can now get going. I would suggest, by the way, you lock the orientation. Now, I don't normally do this for app projects, but it does make it easier to work with animation to stick with a fixed size for now. So lock to landscape. There we go. Okay. Open up Interface Builder using main.storyboard. Then place a button in there. So I search a button in the object library. There he is. Drop it on. I will give it the size 46 wide and 44 high. Remember, 44 is the minimum recommended tappable size by Apple. Is 44 wide by 44 high, so you should use at least that. For X, I'll use 277 and Y 542. So it puts it in the center towards the bottom of the screen. Now for auto layout constraints, what you have to do is select the button from the left-hand view here, then control drag from left to right on it like that. Then let go, and you'll want to choose width and height. So you can hold down the Shift key and tap width, then height to add both those constraints at once. It's orange because it's not complete just yet. That's okay. And now what we want to do is control drag from the button to the view by saying control drag from here to the view, and here are our options. We want to choose center horizontally in container, and also bottom space to bottom layout guide, that one and this one. So I'll press down Shift again and choose center horizontally and bottom space like that. Boom, it goes blue because it's happy. So it'll stay centered and it'll stay towards the bottom and stay at its current size. That's it for auto layout. And so what we have to do now is hook in a title for the button, better than just button. So let's use tap. Boom. Switch to the assistant editor so you can see the code for this. And we want to create an action for this. So control drag from the tap button. Oops, from the button, not from the constraint. From the button down to your code. Make it an action, not an outlet. You will screw that up at least once, don't worry. And make it tapped like that. And press connect. That will be called when the button's tapped. And you can go back to the standard editor now, because pretty much we're done there. So go to viewcontrol.swift. So whenever the button's tapped, we're going to add 1 to a number, and that number determines what animation we're going to work with. So we're going to add 2 properties. First one is for our current animation. So var current animation equals 0. I'll increment up 1, 2, 3, 4, 5, and so on. Each one animating differently. And what will animate is a UI image view. So we'll add another property here called var image view is a UI image view. Now this is not done inside the storyboard. We're going to do it in code, which means we can just load an image and place it wherever we want and move it around all in code. It's quite straightforward. And it's actually super easy to do in code because there's an initializer for UI image view that accepts a UI image. So we can say in view.load image view equals UI image view with image, and for its name image we want to say UI image named penguin. That's the name of our picture. There he is, penguin. And all we're going to do is center it in the screen. There's actually a property called imageView.center equals CG point, and we're a landscape iPad, so it's going to be X 512, Y 384, and view.add subview image view. So we've got a very basic thing there. That places the penguin in the middle of an iPad-sized landscape screen, ready for us to animate. There is one more thing we're going to do if we start looking at animations, and that's to put a little bit of code in the tapped method so that it will cycle through all the possible animations we'll write each time the button's tapped. So what it needs to do is add 1 to the current animation, so we can go to the next one, the next one, the next one, and so forth. But if we go beyond 7, like that, so for 8, 9, 10, and so forth, we want to wrap back to 0. So it'll count from 0 to 7, then become 0 again, and keep on going like that. So there'll only be a certain number of animations. You can press play now, make sure it all works correctly, make sure you've got a basic layout. I'm using iPad Air. iPad 2 is recommended, but I'm sure it's fine just for basic animations. In fact, I know it's fine. There's our penguin, and tapping does nothing at all just yet. That's okay, we'll fix that just now. So, the current animation property, this thing we added just a minute ago, can have a value between 0 and 7, and with each one of those numbers triggering a different animation. Now you might be thinking, what I want to do really is add if-else statements all the way down here, and you could do that. That's fine. That kind of works, but it's ugly. You know, it looks something like this: if current animation is 0, then do anim 1. Else if current animation equals 1, do anim 2. Blah, 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 like that. And that is okay, it's fine, it works. That's the basic way to do it, but it's not the most efficient way of checking a variable for multiple possible values. So most coding languages have a superior method of doing this, known as switch case. Using the syntax, you switch on a value, like this. You say, switch current animation, and then tell it what to do. So what are the possible values? Well, one possible value case is 0, which means the first animation. So we'll say do anim 1. Another one is value 1, do anim 2. So this will be called if current animation is 0, this will be called if current animation is 1, and so forth down the line. Now, this is pretty much the same as the previous code, you know, more or less. But Swift does something extra, which is why switch case is helpful compared to the if, else idea. Swift does its best to ensure your switch case statements are exhaustive, which means that every possible outcome of the switch is catered for. No matter what, something will happen. As a result, you may frequently have to have a default block. If it is none of the above, then do, say, anim 3. And that means if we've not matched anything, do this. Now, if you have coded in other languages before, you may be aware of what's called fall through, which is very common in C. It does not exist in Swift. But if it did, what would happen was, if current animation was 0, it would go, aha, call this, and then automatically also call that one, then call that one. You'd have to write in languages like C or C++ or Java or C#, break, get out of the switch case, don't carry on executing. In Swift, that's been recognized as absolutely stupid, so that does not happen, helpfully. Instead, if you want desperately to execute the other cases, then you'd say fall through like that. And this is sort of helpful if if doing like in the rare cases you're doing an app like the Days of Christmas song, on the 5th day of Christmas, my true love came to me, and you count backwards each time, building up the things you call. Fine, you're going to want to use fall through then, or 10 green bottles kind of thing, that kind of song. Broadly speaking, though, you're probably not going to want to do this, so don't worry about it. You just don't have to specify break. So if you're not an existing coder, that will mean nothing to you. Don't worry about it at all. Now we're going to create a big switch case block here inside tapped. That's going to start small and work our way up to a full thing. And by default, the default block will catch anything that we aren't explicitly catching elsewhere, which is very helpful. We can start with very little and work our way up, because again, Swift wants our switch cases to be exhausted to make sure every possible case is being catered for. And this whole switch case block is actually going to be executed inside an animation block. This is the new stuff. Now, animations use closures several times, actually. There are lots of variations of ways of doing animations, but they're very, very powerful. So what we're going to do is, I'll clear this out a little bit so you can see what we're trying to do. We're going to, when the thing is tapped, we're first going to hide the button. Aha, we can't hide the button because you know what? We haven't got a reference to the button. Silly me. Go back to your storyboard. Go to the assistant editor. Give me an outlet for the button. That makes our life much easier. We'll call this button. Actually, I'll call it tap. Tap like that. Great. There's our button outlet. And now go ahead and hide the button. So we'll say in tapped, tap.hidden equals true, which means the user can't mash the button crazily and expect the animations to somehow figure it out. So we hide the button first, and then we call the animation stuff. Now, animation is amazing in iOS. It's so simple to do because many properties of our views are animatable by default. All we have to say is put them inside an animation closure, and it will do the work for us. Core animation will automatically move them or scale them or rotate them as needed. It's really, really cool. I'll show you a basic example now. So we'll say UI view dot animate with duration. Now there are loads of these. You want animate with duration, and you want to choose ideally options and completion, which is this one. So it's the one just before using Spring with damping. So that one there. So you'll see delay options. So for duration, it's 1 second. Animate over 1 second. Delay 0, start running immediately. Options, we want all zeros. There are lots of possible options, but don't worry about it. Animations, this takes a closure. So we're going to say open brace, then some code, and we need to put in, of course, unowned self in, like that for our closure. And that's going to do lots of stuff. And the last thing, completion, what should happen when the animation's finished, and with another closure. So this method actually has 2 closures, one here, and we're going to use trailing closure syntax for this one. So we're going to just end the call to animate with duration, and then do some more work after, like that. So it's a bit of a strange call. I'll put in completion block there. We'll do some more work on that in a second. So inside our animation block, what we're going to do is our switch case, where we say what's our current animation and take the appropriate action. So that means saying switch self.current animation, because we're inside a closure, we must use self. If it is 0, we'll just do nothing. So we'll put in break, which means do nothing at this point. Otherwise, do nothing. So it does nothing at this point, right? Just try so we can fill in a basic version of the working code. The completion block also must have unowned self in, because it's a closure. But it also must take a parameter being passed in, which is called finished, and it's a bool. Did this animation finish correctly? Oops, like that. Did it manage to finish, or was it interrupted somehow along the way? So you know what kind of state your program's in based on whether finished is true, i.e. the completion of the animation got to its end point, or it's false, it was interrupted along the way somewhere. So when the animation finishes, we have to at the very least, re-show our button. So we'll say self.tap.hidden equals false, like that. And that's enough at this point for a basic animation block. Now you should be able to see nothing actually happens. Yeah, you'll tap the button, it will switch case on nothing and then show itself again. But if you run it back, what you'll actually see is it happens extremely quickly. So tap doesn't appear to go away because core animation detects no work's happening here and just calls completion straight away. That's okay. So let's start adding some actual work in here. If animation is 0, we're going to make the penguin scale up super big. So we're going to say self.imageView.transform. This is a new data type called CG Affine Transform equals CG Affine Transform make scale. This takes a number, 1 being 100%, 2 being 200%. So I'm going to do 2 on the x-axis and 2 on the y. So it'll stretch up nice and big. And default break. Now CG Affine Transform is a way of modifying a view. It can handle rotation, it can handle position, it can handle scale, or a combination of the two. Transforms are a bit of a black art. They're not complicated, but they are requiring mathematics. Fortunately, Apple does all the work for you by giving you these kinds of methods, make scale. There's also make rotation and make translation and stuff. But this one does a scale. So if you run that back now, we should be able to see the penguin scale up when we tap on him. There we go. And see the button re-showed itself. I'll do it again. I'll run it again. So the button goes away. He scales up like that, and the button re-shows itself. Now, by default, these animations are curving, which means they start slow, they get faster in the middle, and they slow down at the end. So it looks lovely and smooth. I'll play it one last time so you can see how it looks. Very nice, very, very smooth. And that's a default in iOS. You can change that if you choose to, but by default, that's basically what you want, let's face it. Now, these transforms are not relative to the previous transform by default. They are absolute, meaning that if you said scale up the penguin to 2:2 here, when it was already at 2:2, nothing will happen because it already has a 2x scale transform. You can't apply a 2x to a 2x. You should be using 4x. So you can't just add them up like that. So this is our first case, scale him up. We'll add a second case, case 1, where we put him down again. So say self-imageView transform equals. Now you could do CG Affine Transform make scale 1:1 back to 100%. But there's another option here, which is CG Affine Transform Identity. Transform Identity, like that. And it means go back to the default transform, as in the original view. Not moved, not scaled, not rotated, nothing like that, just as it was. So we now have, if it's 0, scale it up. If it's 1, put it back to the defaults. Run that now, and you will see, there it goes up, and down again, and then nothing, because of all the other possible numbers, then up again, then down again. So obviously that's because we're wrapping at 8 right now here. So that's why a lot of nothings when you tap the button. So we're going to carry on adding more cases because hopefully this gives you an idea of the kind of thing core animation can do. So we'll say a case 2. If current animation is 2, we're going to move the penguin. We're going to say self-imageView.transform again equals CG Affine Transform make translation. Now, translation is a move in 2 dimensions. So it wants to know a relative amount to move the penguin by. And I'm going to say -256 for X and -256 for Y. So it's going to move it up and to the left. And then let's do case 3. I want to take this same line and put it in again, actually, like that. So back to the identity transform, meaning put him back to where he was. So it should now scale up, then scale down, then move back. Fantastic. All very smooth, all that nice S-curve shape for acceleration. Now we can also use CG Affine Transform to rotate views using CG Affine Transform make rotation. which, as with Sprite Kit, uses radians to rotate. Now, there are some provisos here, just like Sprite Kit. Firstly, you need to provide the value as a CG float. If you type in 1 by hand, fine, iOS can figure out that that just means a CG float. But if we try and use mpi or mpi2 as we were using in Sprite Kit, you must make it a CG float by hand. Secondly, core animation will always take the shortest route to make the animation work. So if your object is straight and you rotate to 90 degrees, i.e. half of pi mpi2 in radians, it will rotate clockwise. If your object is straight and you rotate 270 degrees, so mpi plus mpi2 in radians, it will rotate counterclockwise because it's much smaller to rotate to the left than it is to rotate to the right. So it always takes the shortest route. Now, a consequence of that second proviso is that if you try and rotate 360 degrees, i.e. mpi times 2 in radians, core animation will say, actually, don't move, we're there already. And the same goes for values over 360. For example, if you try and rotate 540 degrees, which is 1.5 full rotations, you end up with just 180 degree rotation because core animation takes the shortest possible route. So with that in mind, with all those provisos in mind, let's add case 4, which is self.imageView.transform equals CG Affine Transform and make rotation. There it is, make rotation. So it wants an angle. I'm going to use CG float m pi, like that. So rotate 180 degrees. You might find you want to import the some sort of degrees to radians conversion if that makes your life easier. But for me, I'd think in radians at this point, so it's perfectly fine. So rotate 180 degrees. Then case 5, self.imageView.transform equals CG Affine Transform identity, like that. So go back to where you were. So now run it back. Let's see how it looks. It should scale up, then scale down, then move out, then move back, then turn around and turn back. Fantastic, looking good. Now, as well as animating transforms, core animation can actually animate many view properties too. For example, it can animate the background color of our image view or the level of transparency. And you can even change multiple things at once if you want something complicated to happen. For example, with the alpha value, which is the transparency of a thing, 0 means invisible, 1 means visible, and we can animate that from 1 to say 0.2 and then back up again, so it fades out and fades in again. And we're also going to change its background color of the image view to green and then to be clear again. I think clear is the default. So let's add some new cases. Case 6, self.imageView.alpha equals 0.1. So go down to like 10% opacity, almost transparent. Then self.imageView.background color equals UI color.green color, green color like that. And then for case 7, we'll put that back. Self.imageView alpha equals 1, as in fully opaque, and self.imageView background color equals UI color.clear color, i.e. transparent background color again. And that completes all possible cases, because when it hits 8, it will wrap around again with this code here. Go ahead and press play. And we should see tap to zoom, tap to put back, tap to move, tap to put back, tap to rotate, tap to put back. And then the new one, tap to fade and color, tap to fade and color. Fantastic. So you can see with this tiny glimpse of its power how wonderful core animation is. But, it is just getting started with core animation, because I'll show you one more thing that will just hopefully blow your mind. It really is powerful. I have written the code exactly like this for a reason, with this exact spacing, because what we can do is we can comment out that line of code and replace it with this UI view.animate with duration using spring with dampening. This method here. Complete that. Again, 1 second duration, 0 seconds delay. For spring with damping, enter 0.5. Then initial spring velocity, enter 5. And options is all zeros. And then just delete the rest of the code because it'll pick up where this one left off. Let me hide stuff so you can see how it works. There we go. So it'll pick up where it left off. That, boom. And now run the code. Check out this. This is really awesome, I think. So it will scale up, but see that lovely bounce effect? He overshoots his movement and his rotation. And also the fading too, like that. And that's using the spring with damping. So this is how fast the spring should stop itself, and that's how fast it should start moving. So I can increase this, you know, so to 20, dramatic spring movement, and you get a crazy spring effect. Like that. It's really awfully bouncy now. Or you could say, you know, I want less damping perhaps, so it bounces for longer, so you get really crazy spring effects. Like that. Don't, crikey, that's hardcore. Don't do that. That hurts my head. But you can really fiddle with these numbers to get a great effect, and it works so easily to do overshooting of animations. I hope you're impressed by that. This is just a tiny glimpse of core animation. You can animate so many things inside the views. Please give it a try. I do recommend it, and please don't think about it as being just for making things look good. It's about helping users' eyes follow what's happening on the screen. So, you know, moving an email to a folder, showing a palette of paintbrushes, rolling a dice, whatever it is, so they can follow things visually as well as functionally moving it. You've also learned about switch case. Switch case is extremely common. You're going to need to use this as a way to evaluate multiple possible values in a concise way. So it's been hopefully a useful tutorial for you. For more information, see the website hackingwithswift.com, where you can buy this as a high resolution video, because you want to see high resolution penguins, don't you? You can also buy it as an ebook for just $3. It's super cheap. Please help support my work. Buy one of them, and I'll help me make more videos. And then you can follow me on Twitter. I am @2straws. If you have questions or better penguin artwork or an amazing spring with damping values, let me know. Follow me. I am @2straws, and I'll do my best to get involved and help you out. Have fun.